Welcome back to the beginner game programming series. I'm Chili, and I've got a bit of a case of strep throat today. Feels real nice, like a Tabasco sauce enema. Yeah. So today's lesson is lesson 20, and we're going to be talking about loading sprites and displaying them. Now you may have noticed that this is not C++. This is actually C#. This has nothing to do with today's lesson. I just wanted to show you guys what I've been up to lately. I've been up to this. It's a little tool I'm creating. It will probably be used in a future lesson. And I'm making it in C# because it's a lot easier to make tools like this in C# using the .NET framework than it would be to make it all from scratch. You can use C++ to access the .NET framework, but I don't know, it's a lot nicer in C#, I guess. C# is actually a really nice language. The only problem is it's so goddamn slow. So no one uses it for real games or anything. But it's real nice if you wanted to make like tools for your, I don't know, like a level editor or something. I don't know. It's pretty good for that sort of shit. And so I've been fooling around with it. If you know C++, it's not that hard to get into C#. And yeah. But enough of that. Today we are gonna be loading sprites up. I know a lot of you guys have been pestering me about this for months already. But I think we're finally at the point where we can do it. So let's do it. I want you guys to create a new instance, a new folder from the framework, preferably the Mark III version of the framework, the newest version. I called mine Sprite. You can call yours whatever the hell you want. And you have to download this zip file. It's the zip file for lesson 20. It'll be on the forum as usual. So you go to the forum, get this zip file, and unzip it into this folder, Chili DirectX Framework, inside of your solution folder. Unzip it here, and here is the graphic that we'll be working on, or we'll be using for today's lesson. And I've created this. It's my own creation, so no copyright or anything. I mean, if you don't want, you could also use you could go on the internet, you could download like sprites from different games like Chrono Trigger or whatever. Sprite sheets are all over the internet, and you can get some if you want to use different sprites. But if you want to follow along exactly what I'm doing, you'll have to use these sprites. Now, the first step in loading a sprite and displaying it is you have to be able to read in a bitmap file. Now, a bitmap file is not a text file. If you try to open it with I don't know, I don't even have a proper choose. Where's a text reader? Notepad, WordPad. Let's open it in WordPad. Yeah, you get garbage, right? This is not human readable at all, except for the first two characters, which are bitmap. That part is human readable. But we can always look at it through, let me see here. Where is my hex editor? Here it is. Always remember to practice safe hex. Ha ha ha. So let's drag my guy on here. Alright. So here's what the bitmap looks like in the hex editor. And again, we have our BM. That's an identifier at the very beginning of the file that tells you, hey, this is a bitmap. And then we have a bunch of numbers here. And then we have a bunch more numbers here. And most of them are Fs. That's right, F is a number. So what does it mean? Well, the astute among you may note that the color white in RGB is FF, FF, FF if you're writing in hexadecimal. And if you're using 8-bit color or 24-bit color, 8-bit per channel, right? Because FF is just 255 in hexadecimal. So we can deduce, looking at the picture and looking at all these Fs, that this data is probably all the pixel data, right? And I'll just tell you right now, although you could probably figure it out from inspection. What? This is weird. Anyways, you could probably figure it out that these pixels, they are 3 bytes. There are 3 bytes for every pixel here. So this is a pixel. It's black. 0, 0, 0, 0, 0, 0. This one is black. This one is dark gray, I would guess. And so on and so forth, right? So we can get an idea, but it's not going to be good enough for loading the files into memory. So how do we load these mothers? Well, generally these kind of files, they have a data portion, which is all this, and they have a header portion, which contains information about the file. What kind of format it's in, its size, its dimensions, etc. So to be able to load the file into memory, we've got to know the format of the data. For example, in these 3 pixels, which one is R, which one is G, and which one is B. That's important. And we also have to know the format of the header for the file. What do all these numbers mean? I think I can tell you right now, I think I know what some of them mean. Like I think this one and this one, they might mean the size, the dimensions of the file, the width and the height. I don't know. But it's hard. You could do it by reverse engineering, picking apart the data, changing the files in a image editor and seeing how the actual data in here changes. And from that you can deduce, you know, what each of these values means, or at least what most of them mean. But that would be a real big pain in the ass. So we're going to use the oft neglected tool of Google. So let's Google this shizzle. We're going to Google it up. Bitmap, where's my keyboard? Here it is. Bitmap file format. BMP file format. Good old friend Wikipedia comes to the rescue. And here we go. This will give us all the data that we need in order to read in a bitmap file. Alright. So let me just open this up and make it bigger and shit like that. So it looks like, what is this? Let me just see here. Okay, byte. So each one of these columns here represents 1 byte. So here's 4 bytes, which is the size of an int. And so the first 2 bytes is the signature. Let's look at our thing here. Alright, that makes sense. First 2 bytes, BM, that's the signature, bitmap. And the next ones are the size of the file. So let's test this theory out. Now we know that the hexadecimal numbers, or the data, when it's written out, it's written with the lowest byte at the first position and then the next highest, next highest. So this number is actually 2FB8. So let's go hexadecimal. 2FB8. And we're going to convert that to decimal. So that's 12.2 kilobytes, sort of, kind of. 12,000 bytes. Alright. Now we'll look at the file here. And it says size on disk 12228 bytes. Perfect. So that seems to be working. Well, it's a little different, but there's could be some discrepancies. It's close as damn it, okay? So that's the size of the file. Let me just get my my thing-a-ling up here again. All right, next thing. Stop it. The next thing here is reserved and reserved. So this means nothing. Now this next number, file offset to pixel array. This is very important because this will tell us how many bytes it is from this position here to the beginning of our image data, our actual pixels. So this tells us where the pixels start in the file. Very important. And then we have DIB header size. This tells us the size of this header, right? This part here. And what else? Then we get image width and image height. I was right, by the way. So these two numbers here, this int and this int, tell us the dimensions of our image, which is also very important, unless you know those dimensions ahead of time. And then we have planes, which I'm not really so sure about. Bits per pixel. Wait, let me see here. Image width, image height. Planes is here. Yeah. And bits per pixel is here. This is 24, by the way, in hexadecimal. 24 bits per pixel, right? 1 byte per image per color channel. 3 color channels, therefore 3 bytes equals 24 bits. So one plane, 24 bits per pixel. Next thing is compression. I'm guessing 0000 means no compression, which is what I used to save the file. Then image size, which I'm guessing is just the width times the height, maybe. I'm not sure. Could be the size in bytes. And a bunch of useless garbage. This is all pointless stuff. We don't have to worry about it. The only real number in here that we're going to be interested in is the offset to the beginning of the data, because we're going to already know the width and the height before we even load the file. So the only thing we're going to really be interested in is the offset there. Now, actually, now that I look at it, some of these FFs here at the beginning, they might actually be part of the header. They may not be pixel data like I thought originally. It's hard to tell. So, let's get to the coding. We got to translate this information into code. We could do it in a number of ways. We could load each of those numbers individually using fread, but we're not going to do that. What we're going to do is first thing we're going to do is something we haven't done yet in the lessons, but very important. We're going to add a new item. Let's add a header file. We're going to call it bitmap. Bitmap, well, these capitals here, bitmap.h. And where is it? Here it is. All right. So we're going to add a new header file, since this code here it's kind of like its own thing. So we're going to give it its own file. And that makes it useful because once we write this code for loading a bitmap and we want to use it in a different project, if it's in its own file, it's very simple to move it over. You just copy the files. Whereas if it's part of like the game file, you have to copy and paste, and it's not as neat. So first thing you do is you go pragma once. you have to do pragma once at the beginning of every header file. And that's just so that it makes sure that the header file isn't included more than once in any one CPP file. If it's included more than once, you'll get errors. Next thing, my throat is really killing me here. Next thing is we're gonna define structures which represent the data of the header file, or of the headers, not the files, they're just headers. So let's see here. Here's my header. So I could create a, for example, struct bitmap file header, header, and then I could do something like, we'll neglect the signature. We won't put that as part of the header because it's complicated, but it's not good to include the signature in the header. So we'll do file size. So we can do int or unsigned int file size, and then we got reserved 1 and reserved 2, and these values are 16-bit values, 2 bytes, and 2 bytes values are signed or unsigned. They're shorts. They're called shorts. Reserved 1. So we could do this. Just look at the look at this information and create the header. But that would not be the smart thing to do, because we're lazy and we like to do lazy stuff. So let's bitmap header C struct. There. Examples of bitmap headers. Word byte. Whatever. Magic? The magic number. I don't like this one. Let's look at this one. Here is the second header. Here we go. I like this header much better. Unsigned short int. Meh. Alright, I'm going to use these ones. There. Suck it. So, it's not my favorite kind of format, so I'm going to reformat this. Wait a second. Alright, that's where I like it. Let's see here. Get rid of this stuff. And what else? Okay, yeah, we don't need this. Like, again, we don't need this first short. That will just get in the way. So here is our bitmap file header. And again, go back to that same web page right here, and we will get this one. We'll call it bitmap info header. This is a little different than the header on the Wikipedia page. That was the version 5 header. This one doesn't have all that information, but it doesn't matter. It has all the necessary information. So wait a second, I'm just going to reformat. Alright, so now we have our 2 headers for our bitmap file. And we'll need to let me see here. Let me think. We're going to need to give the definition of bitmap loading function here. Load bitmap. Alright, so we're going to need a character pointer, constant character pointer to file name. And here's the thing, we have to think of what kind of how we're going to store the pixels in memory. Now there's a few ways we could do it. We could have 3 separate arrays, and each array holds the a color channel, the R channel, the G channel, and the B channel. But that would be kind of ungainly. The other way to do it would be to store them in the native pixel format of Direct3D. If you look at D3D graphics, the actual the format that D3D graphics uses to store pixels in memory is called D3D color. That's the data type. It's basically the same thing as an unsigned int, 4 bytes in memory. And I think that's what we're going to use to store our image in memory, just an array of D3D color data types. An array of D3D color pixels, if you will. So, to do that, we're going to have to include no, not bitmap.h. No, friend. We're not including our own file. We're going to include direct. Fuck it. Fuck it, bro. I'm going to D3D. Yeah, just no. Nah, we'll not do that. D3D9.h. That's what I want to include. There we go. Now, hopefully it recognizes this. Recognize it, goddammit. Ah, you cocksucker. D3D color pointer to buffer. Buffer? Sure. Image buffer. Or surface. We'll call it a surface. Doesn't matter what you call it. It doesn't matter what your name is. Okay, so this is our sole function in the bitmap header file, and that's load bitmap, and it'll take a file name and it will save our bitmap to a surface. We're going to probably make the function more robust later on, but for now we'll just keep it simple. Alright, so what are we going to do? Now we need to add a new file to our project. Add a new item. CPP file. We'll call this one bitmap.cpp. There we go. And we'll include bitmap.h. Get out of that. Alright. Void bitmap. No. Void load bitmap. Okay, why am I not getting IntelliSense? This is kind of gay, bro. Load bitmap. It seems that load bitmap, the actual name of that function is already used somewhere else, which makes sense. It's pretty standard function deal. It's a pretty common name. So we need to think of a different name for our thing. How about load bimp? Sounds good to me. Good. Alright. It doesn't have any problems with that. That's what you call a namespace collision. One of our include files also defines that function name, so we can't define it ourselves, otherwise we'll have a collision and bad shit will happen. Why aren't you giving me IntelliSense, you cocksucker? Grr. You are a bag of dicks. Whatever, bro. Whatever to you. Well, at least it recognizes my D3D color now. Okay. Now, first thing we got to do is we have to open up our file, right? So we do, well, if we're going to open up a file, we're going to need to include stdio.h. There we go. And then we'll do file pointer to BMP file is equal to f open file name. I'm gonna sneeze. I know I'm gonna sneeze. It's coming. Well, it left. We're gonna open it for reading in binary mode. Okay, first we open up our file. Then what? Okay, the first thing we want to do is we want to what? I got it. Car signature 2. And so we'll create this an array of 2 characters. Oh wait, yeah, we'll create an array of 2 characters here, and then we'll do this. F read destination buffer signature size T. Size of car count to file BIMP file. So we're gonna load this signature, and oh god, I gotta do assert, right? Mumble. Assert.h. We're gonna add an assertion in here. # include assert.h. Now, an assertion, I haven't explained this before, but an assertion, assert, let me see, if the assertion is false, and you're in debug mode, that will halt the program and give an error message. So it's very good for I don't know, debugging and troubleshooting and stuff like that. But if you build the program in release, the assertion is completely ignored. It's not included in the program, so it doesn't slow you down in your release. I think I explained this before somewhere. So we're going to assert that signature at 0 is equal to B, and signature 1 is equal to M. So we're going to assert that this is true. And if it's not true, then we better get an error if we're in debug build. So this will do 2 things. First of all, it'll get rid of that signature for us because it's not part of our structure. So we don't want to read it in. It'll screw up the whole alignment of our structure. So in either case, we want to read in that signature, those 2 bytes. But while we're reading them in, we might as well make use of them and check to make sure that the file that we've opened is actually a bitmap file. So now that we've got that out of the way, let's read in our structures. So let me think here. Bitmap file header create our file header. Freed, we'll give it the address of our file header. Size of file header, we want to read in one header, and we want to read it from BIM file. And there you go. That's our whole file header read in. And then we can go like file header dot blah blah blah, and we can get all our data from that. Let's read in our other file header. Bitmap info header freed address of info header, size of info header, 1 BIM file. And that will give us our information. So now we've got two things. First of all, we've got both of our headers and they're loaded up with information. And the second thing is kind of not, let me think here. Yeah, it's not important. We've got our info and that's good. We've got our headers all read in. Now the question is, what are we going to do with that shit? I'll have to refer to our Wikipedia page. So now that we have our hoo-ha and our whatnot, what we want to do is what? We want to find the start of our pixel array. We want to find the start of our image data here. Now that image data, fucking throat, god damn it. Oh man. Let me think here. Colors and file offset to pixel array. All right, so the file offset to pixel array, that will give us the offset from the beginning of the file to the start of the pixel array. So if we want to get to the pixel array, we have to rewind the file, and then we have to seek forward by that many bytes. That will give us our pixel data. Now, let me think. Alright, to be completely honest with you guys, I can't remember where I left off. I just had a pizza and watched some stuff on the internets, but well, let's do this. Let's test out what we've got so far. It's always a good idea, instead of just coding and coding and coding, to code a little bit and then test incrementally. So let's just close this off first, and let us test our little friend. So we're gonna do, we'll do it in here. We're gonna include it first. And # include bitmap.h. I have no idea why that's not showing up. Actually, I have a pretty good idea why that's not showing up. Let's go back to the sprite folder, and yep, the cocksucker put my files in the wrong place. So when this happens, what we do is we delete this file from the project. Do not permanently delete, just remove it. Yeah, save changes. Remove. Yeah, save changes. Remove the files from the project. This might not be necessary, but I'm doing it anyways. Then we're going to copy these ones. I should have created these files in the assets folder. Paste them there. And then back into the project. Alright. Now, if I type include, there we go. Yeah. Okay, now my IntelliSense should be working well. And everything, I feel sick. Load BMP. Okay, wanna load Walking Dude. Walking Dude backslash? Double backslash, remember? Because single backslash means escape character. So you need to put a double backslash when you want a backslash in a text file. Just a little heads up. Copy that. Paste that. So we want to load this one. And we'll just put null in here for now. We're not going to pass it a surface because we haven't gotten that far yet in the load bitmap. But we will put a breakpoint here. And we'll start debugging. See if our build works fine. It might not work. It worked. And we're going to step... Oh, this is not lined up at all. Hope you guys didn't miss too much there. We're going to step into this. We're going to open our bitmap file. It seems like it did not open. We got a bad pointer here. Bad pointer, bad pointer. That's not good. Signature is blah. Right. Wait, no, it worked fine. It worked fine. BMP file. Alright, it's good, it's good, it's good. Never mind. False alarm. Okay, so we've made it so far. We load in our header. Let's look at the contents of our file header. So the size is 12:16. That seems about right. Offset is 54, so it's 54 bytes from the beginning of the file to the start of the pixel data. And we'll read in our info header. What do we got here? So the width of our image is 50, the height is 80. That is correct. Size is 40. I don't know what that means actually. What does that actually mean? I could look it up, but I don't. Then again, I don't really care. What is size? That's the size of the header. I should change the name of that structure to header size. I think I'm gonna do that. Width, height, planes, bits, 24 bits per pixel, compression, no compression, image size, resolution, not important, number of colors, important colors. Okay, good. So, man, let me just get back here. Stop. I'm just gonna change this here. Because this name isn't, it's kind of, header size. I guess this one's file size. There. Make these names a little more, offset to pixel data. There we go. A little more explicit here. Okay, so far so good. We've managed to load up our headers without a hitch. Now what we want to do is, I think this is what I was talking about before, is this one here. There we go. No, there we go. So we have our file offset to pixel array. And what we want to do is we want to jump to the pixel array. That's the next step. So how we do that is first we rewind the file stream, because the pixel array, the offset is from the beginning of the stream, so we have to go to the beginning. So we go rewind and BMP file, and then we go seek fseek, that's the one, BMP file long offset int origin. Let me think. I need to look this up. Let's go fseek and we'll go to the C++ reference, our old trusty reference. Please load. Good, thank you. Okay, origin. Oh, we could seek for the beginning of the file. We don't even need to rewind. Number of bytes from origin. Alright, so seek set. There we go. So here we go. Offset will be file header dot offset to pixel data, and the origin will be seek underscore set. Now we don't need rewind because this seek will automatically seek from the beginning of the file, so saves us a single function call there. So now we have seeked to the beginning of the pixel data. Now we just load the pixel data into our array here. So how do we do that? Well, let me think here. Basically, we're going to read in a number of pixels from the file. How many pixels? Well, the number of pixels is just the width of the image times the height of the image, right? That equals the number of pixels in the image. So we go for int index is equal to 0 as long as index is less than info header. Let's pre-calculate this value just for the fun of it. Int Oh, let me think here. Array size. Surface size is equal to info header dot width times info header dot height. Yeah? That seems about right to me. That might be the value of image size, but no, that's not. No, it's not. That's not. Okay. So that's our size. So then we go, as long as index is less than surface size. Fuck that. In pixels. That's way better. In pixels. There we go. Index plus plus. Okay, so for every pixel we have to read in the pixel from the file. Now the question is, what order are the color channels in? You would think RGB, right? So the first byte would be R, the second byte would be G, and the next one would be B. But you would be wrong. If we look at the Wikipedia page here, a 24-bit bitmap with width equal 1, meaning the width of the image is 1 pixel, would have 3 bytes of data per row. Blue, green, red. So the order is BGR. So let's make a bitmap pixel. Let's make another structure. Bitmap. Struct. Pixel 24. Okay, that was blue, green, red, right? Let me think here. Blue, green, red. Right. Okay. So we have there. Let me just make sure. I want to make sure I got this right here. Okay. Red pixel is the last one. Blue pixel, green pixel. Okay. So seems like the order should be blue, green, red. Now, let's go back to here. So for every pixel in the image, we want to pixel 24 pixel. Now we're going to read fread. Address of pixel, size of pixel, 1 pixel. Yeah, that's what we're going to do. And file is bimp file, of course. Next, now we have to store the pixel into the surface. So we go surface at index is equal to, and here's the trick. Let me just show you here. Photoshop here. Good. So in the file, you have your individual pixels. Here's 2 pixels, let's say, and they have their blue, green, red bytes. Blue, green, red, and we read this into a structure in memory. This is in file. This is in memory. Blue, green, red. And now we want to store this into a surface. Which is an array of D3D color values. Right? Each one representing a pixel. And D3D color has a different order. I don't even know the order, but let's say it's X for not used and then GRB. So how we do this is we have to reorder the bytes, the order of the bytes in here. And DirectX gives us a function that lets us reorder the bytes. Let me show you. So for example, for our putPixel function, we got our bytes in 3 integer values. We got our R value, our G value, and our B value. And in order to put that onto the screen as a D3D color, we had to use this. This is called a macro, actually. It's kind of like a function. And we pass it the RGB values, and it will pack them together into a single 32-bit value and in the correct order. So we need to use this. I'm going to copy it. And now we'll do pixel dot red, pixel dot green, and pixel dot blue. RGB. And if we do this for every pixel in the image, we should have good times. All right, let's try it. Step in. Yeah. So let's read the first pixel. What is the pixel? 255, 255, 255. It's white, which is expected, right? Because the image is mostly white. Wait a minute. Oh, unhandled access. Okay, yeah, access violation. That would make sense because we haven't actually given it a surface to write to, right? Look at our game.cpp. We just gave it a null pointer, which is a pointer to nothing. So if we go D3D color surface, and I think our image was 50 times 80. So we'll make it 50 times 80. That's the size of the image, the size of the array. And then we pass it the surface. Stop debugging. Build. And start debugging. Step into. Over. Here we go. Alright. And now we are filling up our array with pixels. And step out. And we're finished. And run. And there you go. We've loaded our image file. Now the next step is we have to display the file onto the screen. So let's make a function. Void draw surface. Int x, int y, the position to put it at, and D3D color pointer to surf for the surface. Ah, cocksucker. Actually, we'll make this a constant D3D pointer because we're not changing anything on the surface, so might as well leave them constants. Yeah, let's do that. Now what we want to do is copy this. Go in here. Draw surface. Now the basic idea here is we're just going to call put pixel, and we're going to stuff our pixels into memory at the correct spots. So let me think here. The thing is, though, is that in this case we don't have RGB, separate RGB values. We just have D3D color values. So our current putPixel function is going to be a kind of a pain in the ass. So we're going to make a new putPixel function. Void putPixel int x int y d3d d color C. And it's going to be almost the same as our normal putPixel. Where is it? Where did you go? So where's our normal putPixel? Where is it? Here it is. Copy that. Except instead of RGB, we just have D3D color C. Only difference. And here we don't have to convert. We can just directly move C into the correct spot in our back buffer. So that works like that. And as for draw surface, it's a very simple process. Let me show you. Wait. So x and y are our starting x and y values. So call it x off and y off. X offset, y offset. This x and y, by the way, are x and y in our let me see here. In our surface, our bitmap surface, which is going to be drawn onto the screen. That's what this x and y represent. So we start off with 0. Fuck. I always want y to be the outer loop. As long as y is less than... We need more information here. We need x offset, y offset. We also need int width and int height. We need to know the size of the surface, because this is just a pointer to an array. We don't know how big the array is. We don't know the width, the dimensions of it. So if we don't know that information, we can't copy it to the screen properly. So we need to get that information. As long as y is less than height, y plus plus, for int x is equal to 0, as long as x is less than width, x plus plus. And then we copy these values to their respective locations on the screen, but we add the x offset and the y offset. So we go putPixel. Gotcha. I am hip to your games. No, not game. D3D graphics. Draw surface. Fuck you, man. Fuck you, bro. I don't care about that. What have I got here? Now I want to do putPixel, and x is going to be x plus x offset. Y is going to be y plus y offset. And the color, C, is going to be our surface at x plus y times width. This is just our very, if you remember back to, well, for example, our tic-tac-toe game. This is just converting two-dimensional coordinates into a single flat array coordinate index, right? The x coordinate plus the y coordinate times the width. All right. And that's that, really. That's all she wrote. To copy an image onto the screen, that's all you need. Now I need to put this. No, I already got it here because I copied and pasted. Good old copy and paste. What I'm going to do, though, now I'm wondering even if I want to make bitmap a separate thing. I could make it part of D3D graphics. It doesn't need to be part of graphics, but wouldn't hurt. I'll leave it separate for now. Alright, so now I should be able to copy a bitmap to the screen. No, I can't because I failed. Oh yeah, because I changed the signature of the file here, but I didn't change it in here. So let's draw a surface. Just change it here. Good. Good. Okay, now let's test this. Let's test this theory out. Game. Okay, we're going to take this and we're going to move it into the user variables here. And next we're gonna, this will stay the same, we'll just load this into the surface. Now for compose frame, graphics dot draw surface, we're gonna draw it at, I don't know, 400. Now the width was 50, the height was 80, and surface. Alright, so let's see what kind of craziness we get up to here. I'm pretty sure this is not going to work properly. Okay, we get blackness. That is worse than what I expected. Why? Why do you hate me? Let's try, Alright, let's look at this here. Okay, x equals x offset, y equals y offset. Why did I put an equals in here? I'm going to blame my keyboard on that one. I blame my keyboard on a lot of stuff. It's all because it's true. Build. Okay, let's try it now. Okay, this is better. But as you can see, it's still rather fucked up. And by rather, I mean considerably fucked up. So, why is it being fucked up like this? Well, there's a good reason. There's a very good reason for that. Now, it just so happens that computers, especially x86 computers, where's my thing here? Pixel format, here we go. Computers like to have things line up in multiples of 4 bytes. So, here we go. Padding bytes must be appended to the end of rows in order to bring up the length of the rows to a multiple of 4 bytes. So a row has to be a multiple of 4 bytes in an image. Now let me just where do we have my, here we go. So every pixel we have has 3 bytes. So let's say we have an image here, and that image is 1 pixel wide and 4 pixels tall. So here's the image blown up. 1 pixel wide, 4 pixels tall. In memory, it'll look like this. Or in the file, it'll look like this. Here are our bytes for this image. Here we have our, I forget what it was. I think it was like blue, green, red or something. Yeah. 1 byte, 1 byte, 1 byte. However, every row has to be a multiple of 4 bytes. And for 1 pixel per row, every row will actually only be 3 bytes. So what it does is it adds another row, another byte at the end of every row. And that's called a padding byte. Padding. And that's just to make it so that every row is now a multiple of 4. But if you read your data in and you don't take into account the padding, your first pixel is going to be read in here, but your second pixel is going to start from this garbage padding and then read here. And then your third pixel is going to have garbage padding in the middle and so forth. So your first pixel will be fine, your second one will be shit, your third one will be shit, and your fourth one will be shit. Right? 1, 2, 3, 4. And you won't even be reading in this last one here. It's be all fucked up. And that's what's happening to our image. It's getting all fucked up because our padding is wrong. So we have to calculate how much padding we need for every row. So let's do that now. So how do we calculate padding? Well, let's go to our bitmap file thing here. So number of pixels, width times height. Okay. Int. There's a nice long file name, or a long variable name for you. Number of padding bytes per row is equal to let's just do this the old-fashioned way. Now we'll just say we'll say that we already know that it's a 24-bit image. We're assuming 24-bit bitmaps. So if your bitmap is 32-bit, this will not work. We're going to assume 24-bit, since we're assuming 24-bit down here anyways. So in the case of 24 bits, the number of bytes of data per row is equal to info header dot width, fuck you, dot width space times 3, right? 3 bytes per pixel. So that's the number of fuck that. Number of bytes per row is equal to this. And int number of padding bytes per row is equal to the number of bytes per row mod 4. That'll give us the remainder if we divide. And the remainder is equal to the number of padding bytes that have to be added in order to make it a multiple of 4. So we want the remainder here. What am I doing? Let's not do this. Let's do this. Let's do that. Let's do that. Do that just to be safe. There we go. No sense in unnecessarily adding a new variable there. So we get the number of bytes of data, and then we mod 4. That's wrong. This will give us the number. Right. For example, let me just show you what's going on in my brain right now. If we have 1, the width is equal to 1, and again 3 bytes per pixel, 1 pixel per row, well, it will be 3, right? 3 bytes per row of data. 3 mod 4 is equal to 3, right? But the padding is not 3. The padding is actually 1. So what we want is the number of bytes mod 4, and then we want 4 minus, right? Because this is actually the number of bytes that will be number of bytes in a not full group of 4. And so we've got to subtract that number from 4 to get the number of bytes that we need to add in order to make it a multiple of 4. Does that make sense? That's complicated, but I hope you understand what I'm trying to say here, right? So if we had, like, let's say we had an image that was 2 pixels wide, right? So in that case, we'd have 3 bytes here, 3 bytes here, right? 1 for each pixel. But as far as the computer is concerned, we have 1 full group of 4 here, and then we have 1 empty group of 4 here. So we have 6 bytes of data per row. 6 mod 4 is equal to 2, right? That's the 2 that are left over. So to get the number of padding, which is here, we have to take the number left over, 2, and we got to subtract that from a full complement of 4, and we get 2, which is the number left over. And same thing here, 3 mod 4 equals 3, so we do 4 minus 3 equals 1 padding byte. Alright, that's the padding calculation. So let's factor that in here. Where is it? 4 fucker. Double fucker. Holy shit. You're just fucking me all over this time. 4 minus this thing here. And that is equal to the number of padding bytes per row. Now what we do is, after we've read in a single row, this isn't going to work, is it? Because we don't know when we've finished a row. So we have to make this more complicated now. Fucking whatever. Whatever, bro. You don't phase me, bro. You don't phase me. Okay. Y is equal to 0. As long as y is less than info header dot width y plus plus. I think I'm not going to need n pixels anymore. I don't think that's going to be necessary. Tab that one. X, as long as x is less than info header dot height. I said height. I said height, bro. Yeah. X plus plus. Then we do this, and then we do this. Okay. Now we're doing a two-dimensional looping through the stuff. Yeah, through the stuff. We're going to read pixel. We're going to put that in here. Now it's not going to be index because we don't have index anymore. So what it's going to be is it's going to be x fucker plus y times info header dot width. There we go. That's a mirror image of what we do when we're drawing it now. And the last thing we do is, when we finish this loop, which is the end of a row, we're going to fseek bmp file. Offset is equal to n padding bytes per row. We're going to seek forward a number of bytes equal to the padding bytes. The origin of our search is going to be from the current position, which is seek cur, I guess. I'm going to take a guess and say that's what it is. Now this should load it properly, mostly properly. The truth is we still have a problem. Oh god, that made it worse. That made it worse. Okay, I got my width and my height backwards. That will always make it worse. That will never make it better. As a corollary. Width. There you go. Now it should be better. But still not perfect, because as you can see, our dude is upside down now. Oh, the trials and tribulations of the walking dude. Now here's a funny little piece of trivia about bitmap files. Bitmap files store their pixels upside down. Don't ask me why. I'm sure there was a good reason for it at the time. Probably says that in here somewhere, but let me see here. Upside. Right, pixel array. The pixel array is a block of 32-bit D words that describes the image pixel by pixel. Normally, pixels are stored upside down with respect to normal image raster scan order. That's retarded, but that's the way it is. So what we have to do is we have to load it into our surface in reverse order. So how do we do that? Well, instead of using Y, we use info header dot height minus Y. And I believe we have to subtract an additional 1 from that. Height minus, fuck, where's my minus key, fucker? There it is. Height minus 1 minus Y. So in this case, when Y is equal to, well, let's say our height is 80, right? So that means that Y goes from 0 to 79. And so that means that when Y is 79, or when we're at the end of when we're at the final row of our bitmap, we're going to be writing to 79 minus 79, or 0, which is the first row, right? Likewise, when we're at the very top of our bitmap, Y will be equal to 0, and we're going to be writing to row 79 of our surface in memory. So it flips it around. This will flip around the order in which the rows are loaded into our bitmap in memory, our surface. Alright. Now let's try it. And hallelujah, we have a winner. Awesome. Totally awesome, bro. Look at that. It's a dude, and he's standing in our window and stuff. So we've loaded a bitmap, and we've drawn it to the screen. Now, let's up the ante a little bit here. Now what we're going to do is we're going to draw it as a sprite. So I'm going to change this thing here. Now to draw it as a sprite, you have to have a transparency color. That's a color that that's not drawn to the screen. So what we want to do is we want to add a another parameter to this thing here. We'll call it D3D color key. That's the color key. To the graphics here. There's our color key. And if the current color is equal to the color key, then we don't want to draw it. So C is equal to, so we load the color from our surface. The first thing we do. Then if C is equal to our key color, if C is not equal to, then we put that pixel onto our screen. Otherwise, we just skip that pixel and we move on. No. So 5 arguments. So we're going to draw this, and we're going to draw it where's my thing? Where is it? D3D color XRGB. Okay, game? Yeah. And it's going to be 255, 255, 255, right? White. Our key color is going to be, oh wait. If I do that, my guy is black and the screen is black. So I won't see anything, right? I'll actually see something. I'll see his gray. That was the anti-aliasing, but that won't look good. So what we're going to do is we're going to change the background color. Very simple change. It's in D3D graphics. We have, what is it? Clear. So here is the clear call, which clears the screen. And this D3D color is the actual color that it clears the screen to. So we're going to change the background to white. And you still? Draw sprite. I changed the name, but I didn't change the name here. I guess I'm gonna have to change it here too. Okay, let's try that again. Hallelujah. And here is our dude on a white screen. The white screen hurts my eyes. But it can't be helped, because the dude is black. And black dude on a black screen is not good times. So there's our dude. And he's drawn on the screen with transparency. Meaning he's a sprite. Now, actually, now that I think about it, I just took another break, by the way. But now that I think about it, let me think here. There's a better way of doing this here. I just want to show you. Where is it? Bitmap. That's what it was. Yeah. So obviously, as you can see, this works fine for loading the data in the correct orientation. But it's not the most intuitive solution. So here is another solution that makes more sense, actually. We're going to loop through our thing here. What? Our surface. We're going to loop through our surface in the Y direction in backwards. And that will be more intuitive. So we're going to start Y is equal to info header dot height, right, -1. And as long as Y is greater than or equal to 0, Y minus minus. Now we're looping, we're starting at the bottom and we're looping our way up. And that way we don't have to transform the y into its flipped version when we access the surface. We're just naturally looping from the bottom to the top. And x is looping from left to right as usual. So this should work. I'm just going to test it before I move on. Let's keep going. There we go. Okay, good. Now we have a decent solution here, but I don't like it. I don't like it the way it is. I want to make it a little more structurized, structural, whatever. I'm going to add a structure. That's what I'm trying to say. So we'll go to game.h and we're going to make a sprite structure. We'll make it outside the game class, I guess. We can make it inside the game class too. We'll make it inside the game class, whatever. Public struct sprite. So what things does a sprite have to know? Well, it has to know its width. So I'm making it unsigned. You can make it signed or unsigned. It doesn't matter. It'll work the same in the end. It needs to know D3D color. It needs to know its color key. And it needs a D3D color pointer to its surface. So a sprite structure will hold these kinds of data. And now I'm going to change draw sprite. So draw sprite will just take a pointer to a sprite. And let me look at yeah, I'll have to change this one too. There. Include game.h in here. I'm wondering if I should make a sprite part of the graphics now, or should I make it part of the game? I'll make it part of the game. We'll see how that works. Okay. Now, draw sprite. Actually, sounds like it would make more sense to make it part of the graphics file. Yeah, that's what I'm going to do. I'm going to make it part of the graphics file. I'm not going to make it part of the graphics object, though. So we'll go to game.h. We'll cut that out. Delete that. Not that it matters. And d3d graphics.h. I'll put it at the top here. There. And that will be fine. Now, height is going to be, so we're passing the sprite object by address. We're passing it a pointer to the sprite, not passing it the object itself. So if we want to access a member of the sprite object, we can't just go sprite dot something because this is a pointer. It's not a structure. We have to dereference it to get it to be a structure. But if you dereference and you put a point after it, it won't work. The reason being is that the point, the structure member accessing operator will come before the dereferencer. So first it will try to access the member, but it's not a structure, so it doesn't work. So what you have to do is you have to dereference it first by using brackets, and then you can access the member. See, we got our IntelliSense, and now we can do height. Right. Now that's one way of being able to access the members of a structure using a pointer. Now the other way, there's a faster way of doing it. And that is you do sprite, and then you put a minus sign, and then you put a greater than sign. And that will let you dereference it and access the member all in one shot. So it's a little shortcut there. Sprite pointer to height. That's not what that says. That's saying dereference sprite and then access the height member of the structure which is pointed to by sprite. And the same thing here, we can go copy, paste sprite pointer to width, that's not what I wanted to do. Key width. There we go. Oh yeah, and surface. And surface there too. I wanted to change, I forgot, I wanted to change this. This should just be C, right? Because we load this value into C. So we don't have to access surface twice. We can just use our local C value. Good thing I caught that. That's what I intended to do the whole time. That's why I created this variable here. Alright, so that should work, except, of course, now our draw sprite does not take 6 arguments. Yeah, okay, so now this is all messed up. So what we should do is we should go into game here. We create a surface, and then we create a sprite, call it dude. So we first will load the surface. And then we go dude dot height is equal to 80. Dude dot width is equal to 50. Dude dot key is equal to D3D color X RGB to 55 to 55 to 55. There. And dude dot surface is equal to surface. There. So we load up our surface, and then we initialize our sprite object. And then when we want to draw, we can just pass it the address of the sprite. No, wait, which is dude. Dude! The dude abides. I still got a failure. Surface not a member of sprite. Signed, unsigned, mismatch. That's fine. I don't care about that, but I do care about this because this one is surface. There we go. Beautiful. Beautiful. Alright. So it's looking a little bit better now. A little more like I like. Now just for the fun of it, we're going to make a load sprite function. Just because I feel like it. So, that's not what I wanted. That's what I wanted. So here's we'll make it outside of the graphics object. Just because I don't know, I feel like doing that. So, void load sprite. So to load a sprite, we need to pointer to the sprite object that we're going to load up. And we also need, wait, that's not right. Sprite pointer to sprite. And we also need a D3D color pointer to the surface that is going to hold the sprite data. And then we need a constant car pointer to file name. And then we need unsigned int width, unsigned signed int height, D3D color key, and that's it, I think. This is our load sprite function. We'll put it right here, because then I don't have to scroll to the bottom. Bonus. Alright, so we'll just do what we did in the bitmap, basically. I mean, in the game.cpp thing here. Cut that out. There. Paste that there. So we want to load file name into surface. Then we want to set the heights and widths of our sprite equal to the values there. And dude.key is equal to, it's not equal to G, it's equal to key. And dude.surface is equal to surface. Alright. So now we can have a single function that will load up a it'll load up a bitmap onto our sprite. Now we can just call load sprite. We'll go back to game.cpp. Address of sprite and a pointer to our surface, and a file name is, oh, I shouldn't have deleted that. Walking dude double backslash I forget. That's not what I wanted. Here. There. And what else? Width is 50, height is 80, and D3D color underscore XRGB 955 blam blam blam. Okay, so that'll do that. That's the same thing. It's just, I don't know, I like having a function. I like making functions. Making functions making me happy. Errors. Right. Because this is a pointer now, so we need to use pointer referencing. Like that. La dat. And also it's not dude, it's sprite. So I'll have to change that too. One thing at a time. There. Are you happy now, dick face? No, apparently not. Sprite is yeah, because it's dude, right? Dude. It's not sprite, it's dude. Now, load bimp. Because D3D graphics does not include bitmap.h. Now I can go to game and I can get rid of this. Not that it matters, because it doesn't. There we go. Lovely. Purty, so purty. Alright, so, yeah. Now let's animate this mother. We're going to animate our walking dude. Alright, let's get on it now. We go on to create. I'm gonna go to game.h. Now an animated sprite, this will be part of our game class. And it's gonna be a structure. Public. Animated sprite. So what kind of information do we get in our sprite? Well, sprite so we have an array of sprite structures, which is an array of the frames of the animation. And we're going to have unsigned int n frames. What else? This is actually going to be called animated sprite template. Now the reason why I'm making a template is because you might have a single sprite, but there might be, you know, multiple copies of it on the screen. It happens quite often, right? With like enemies on the screen, right? You might have like 10 or 20 of the same enemy on the screen. And you don't want to load up a separate set of sprites for every single enemy. What you want is you want to load up one copy of that sprite into memory. And then you want to have a bunch of different enemy structures which reference that main template structure. So this is the main template, and it will just have information. It'll have the array of frames. Let me think here. Yeah, it'll have an array of sprite objects, which is an array of the frames. And it will have a number of frames. Now, what other information? This is going to be a very simple animation, so the time between each of the frames will be equal. So unsigned int frame duration. So that's the number of frames that the animation should be held for. Could also do it by time, like number of milliseconds, but we won't do that. Not this time. That's for later. So the number of frames, frame duration, and the actual array, a pointer to the array of frames. What else do we want? I think that's about it. And then we're going to have another structure, which is just animated sprite instance. And it will have a animated sprite template pointer to the template. Ah, template can't be used. T. Template. It's the best I can do. Template is a protected word. And unsigned int current frame unsigned int current frame exposure exposure there we go. Current frame exposure is the number of game frames that the current frame has been displayed for. It's to keep track of when the frame will have to be advanced. Alright. Now we have our all of our sprite data types here. It's time to make some sprite functions. So game, what are we gonna have here? Load animated sprite. And we need a should be void animated sprite template. So we need a pointer to the template that'll be loading. And what else do we need? And we need a sprite pointer to the array of sprites. And we need, yeah, that's wrong. This should be a star because it's a pointer. Ampersand gives you something that's similar but different. And we need a surfaces. We need a pointer to the array of surfaces that will hold the surfaces and the array of sprites that will hold the sprite information. And a pointer to the template. Error type. Animated sprite template. Ah. I gotta say that this is a structure. Struct. There we go. Load animated sprite. So let's implement this mother. Alright. Game. No members available. That kind of sucks, bro. I'm not gonna lie. Okay, good. We've got our IntelliSense, and it's all good. Okay. Load animated sprite. We're going to need more information if we're going to load an animated sprite here. This is not enough information. We're going to need a buttload of information here, bro. Okay. Where to get started? Constant char pointer to file name. Base name. We'll see why I called it base name in a second. What else? I'm just getting lazy. Typing unsigned, just it's too much work. We need the width, we need the height, we need the color code, key code. What else? We need the number of frames, right? This the order of these arguments is kind of willy-nilly, but nilly-willy, I don't know. It's good enough for government work. Okay, here we go. There. Now we got lots of arguments, bro. Tons of parameters. Let's use these to make a sprite template structure. Load it up. So, first thing we got to do is we have to load up all of our sprites. And before we can load up all of our sprites, we have to load up all of our surfaces. So, for int index is equal to 0 as long as index is less than n frames. Index plus plus and load, wait. Load sprite. Good. Sprites, address of sprites at index. And the surface would be address of surfaces at index. File name. This is going to be complicated because the file names is equal to a base number plus a digit here. So we're going to use some magic. Bah. Yeah. Okay. To get our file name, we have to take a base name. The base name in this case is wdude, and we have to add to that a 00, and then add to that a .bmp. Now, how we do this? If this was, for example, console output or printf file output, we could use fprintf, and we could format a number into our thing. Yeah, real technical there. I'm getting technical now. Into our thing, into our string, right? Our file name string. But this is not file. We're not having a file here, and we're not having a console output. We just have a string. So what do we do, people? What do we do? Car. Buffer. I don't know, 64. If our file name is bigger than 64 characters, we're just fucked. Now what we're going to do is sprintf. This is string printf. So in this case, the destination isn't a file, and it isn't the console. The destination is a string. So we can give it the buffer as a destination, and then we tell it, okay, we want you to put a string, and then another string, and then not a string, and then a number. But that number has to have at least 2 digits. So let's go to our trusty C++ reference here. This is going to be a long episode, isn't it? sprintf. D, where is D? Integer. Okay, that's good. Width. Precision. Length. Number. Minimum number of digits to be written. The value to be written is shorter than this number. The result is padded with leading zeros. Okay, this is what we want. We want leading zeros if the number is smaller than 2 digits, right? So what we do is we go d.2, and that'll mean that minimum 2 digits. So if the number is 0 or 1, it won't just print a 0 or a 1. It'll print 00 and 01. Minimum 2 digits. Padding with leading zeros. And then we want to put dot, this is just a normal dot, bmp for the file name. And into this, we will format our base name, and we'll format index. And that will give us, it'll give us a file name based on the index of our loop plus the base name. And it'll add bmp to the end of that to give us our file extension. And that is another reason why I told you that printf is going to be very useful. Not just for fprintf, but also for sprintf, formatting numbers into our strings. Alright, so now we have our buffer. File name buffer. That wasn't a very good variable name there. I fixed it. I fixed it, yo! Okay, next thing. Width is just equal to width. Height is equal to height. And D3D color key is equal to key. So now we load up all of our sprite objects. And subsequently all of our surfaces too. They get loaded as a consequence. Now that we have all of our sprites loaded up, now we want to finish the deal by fixing up our template. So we go templat pointer to frames is equal to sprites. And then we go templat pointer to n frames is equal to n frame. And templat pointer to frame duration is equal to frame duration, which I did not include here. I'm gonna get so many friggin' error messages because this is int and that's unsigned int, isn't it? Yeah. Why do I decide to be lazy one moment and then, I don't know, OCD on the other moment? I have no idea. Okay, we need int. I said int, bro, int frame duration. You know what I'm going to do here? I'm going to get rid of all these unsigns. Screw it. We don't need the extra space anyways. I mean the extra range. I'm going to get rid of this one too. Make my life easier. Failure. Syntax errors. Surface. What's your problem, bro? Alright, because there is no such thing as a surface. It's a D3D color. Right. I knew that. That made things a lot easier. There we go. Build. Okay, yeah, unsafe, I got you. Okay, so now we have a function that will load a sprite. Well, it should load a sprite. We have really no good way of testing it. I could just run it and make sure it... Nah, I won't even do that. Fuck it. We'll figure it out later. Well, I could try and test it a little bit. Yeah, let's just do a little test here. So we need to... Oh, God. Alright, here's the dealio. We're going to create a bunch of define constants here. So we got dude width is equal to 50. 1 second, I'll be back. Alright, so here's all the constants that define the dude. So you can just put these in here. You can also, like, if you can put #define dude key color, and then you can put like a whole expression like this in there. You can use strings, you can use stuff like this. It's all good. You can even use a previous define in a later one here. So these are all of the numbers and the string that defines the dude sprite. Now, for the surface, this is actually going to be, logically, it's an array of separate surfaces. But really, it's just going to be, it's actually an array of surfaces. logically. But really, it's going to be just one giant array of pixels, and all the surfaces are going to be stored in it one after another. So the size of the array is going to be, we'll just do this one, dude surfaces, dude height times dude width times dude n frames. And that's the whole shebang. That's all the animation frames in one giant thing. Now, that's not what I wanted. This will make things more complicated. And I'm going to have to rewrite that function I just wrote. There's a better way of doing it, but in order to do that, we're going to have to learn something that I'm not going to teach you in this lesson. So for now, we're just going to do it this way. We're going to put all the frames in one giant array. Yeah, that'll work. That'll work. Next, we want sprite, dude sprites. And this will just be dude n frames. Right. And then sprite, animated sprite template. Dude template. Alright. Now, like I said, we're going to have to fix up our loading function here for stuff. Right. So it's not surfaces at index here. It's going to be surfaces at dude width times dude height times index. Right? So when index is 0, it's going to be location 0. And at index 1, it's going to be the location after the first surface, right? Because one surface, it takes up width times height pixels. So 1 times width times height will bring us just past the end of the first surface. And 2 times width times height will give us past the end of the second surface, and so forth. So by doing this, we can access the individual surfaces, which are all crammed into one single array. It's not pretty, but it works. And that should work. Or not. Right. Now we want to get rid of this here. And we're going to go load animated sprite. Okay. Pointer to template. Wait. Dude template? Is that the name? Is that what I called it? Yes, it is. Good. Come back. And we want dude sprites. And we want dude surfaces. Base name. Dude file name. Height. Dude height. Fuck, that was width. Don't want to get those mixed up. Dude height. Dude key. Dude n frames. Dude duration. Is that what I called it? That's not what I called it. We're just gonna hit the new line there. So dude end frames, that's good. Dude duration is not, that's not a word. Dude duration, sorry, that's not a word. That would be under game.h. Dude frame time. I was close. And by close, I mean I was nowhere near it. Okay, load animated sprite. There we go. Failed. Dude key. Dude key color. Bingo. So now we've loaded our sprite. Let's try and draw a sprite. So we'll draw, what am I going to do here? We'll just try a very simple animation here. We're going to need to add a variable to our game though. Get rid of this one. That's not useful. Int frame number. So on our go, what we'll do is frame number plus plus. Here we want to do frame number equals 0. So increment frame number. And we do frame number mod and equals number of frames. We don't want the frame number to exceed the number of frames now, do we? No, the answer is no. Then we want to draw dude template dot wait template, let's go back, dot frames at frame number. Just a very simple test. This guy is going to be walking super fast. If wait, all right, I've got to give the address of this frame, which is a sprite. Why do I get the feeling that this is not going to work? Yep, it didn't work. God damn it. Stream is not equal to null. Looks like I failed. Where? Reading the bitmap file. wdude0.2.bmp. Ah, my formatter was fucked up. My I gotcha, bro. Simple problem. Very simple. Let's fix it right now. Game.cpp. Game, bro. I said game. Here, load animated sprite. Alright. I think the dot 2 has to come before the D. Now it should work. Better. Well, we got another debug assertion. Break. Let's go here. wdude00.bmp. That's better. but it's still not opening the file properly. Right, because I'm a retard, and because go to game.h, this has to have the it's got to have the path name here. Otherwise, we won't be able to open. See all these fun little bugs that you run into when you're coding. And the dude's walking now. He's really going. Look at him go. Oh my god. Alright. So that's walking dude test. And so far, so good. Now all we have to do is make it nice and smooth. So I'm gonna implement a few more functions here. The next function that we want. God, this is taking so long. Next function that we want is create sprite instance. So we want to create an actual instance of a sprite template. And here okay, so we want a pointer to a template. And then a pointer to an animated sprite instance. This will be simple. This one will be easy. Instance. It's going to be so much better once I can teach you guys, or once you guys know dynamic memory allocation, which is coming next lesson, by the way. Alright, so create a sprite instance here. So we go instance pointer to template is equal to template. And instance pointer to current frame exposure is equal to 0, and instance pointer to current frame is equal to 0. Basically just zeroing it out. Oh, sprite instance needs other data. I thought we were missing some stuff there. Sprite instance also needs its position, int x, y. There we go. Instance pointer to x is equal to 0. Pointer to y is equal to 0. So we just clear out the sprite and then make it point to our template, and then we're finished. Very simple. And now if we're walking, we want to update the sprite. So let me think here. How do I want to work on updating the sprite? Just a very simple function that loops through the animation. That'll be fine. I'm gonna make the position of the sprite, I'm gonna make it a float. Because that worked nicely for me in the past. Okay, now void update animation. Just a pointer to an animated sprite instance. And void draw sprite instance. And there's another one that'll take a pointer. All right. Oh my god, my throat is killing me now. Why did I decide to do this? What did you do? Undo that. Okay. Now, update animation again, very simple. If instance pointer to current frame exposure is greater than or equal to instance pointer to template pointer to frame duration, which is the length of time that any one frame will be displayed before it's cycled. Then current frame, wait. Instance pointer to current frame, pointer to current what? Pointer to U. Current frame, increment the current frame, and then mod and equals what? Instance pointer to template pointer to n frames. We don't want, you know, the current frame number to exceed the total number of frames. And again, now we have to reset this. Alright. So that'll cycle through the frame. That's all that's necessary for. Update animation. Now draw sprite instance. This one should also be pretty easy. Fuck off, bro. Okay. All this will do is basically the same as this, only a little bit different. The same but different. So this will be int instance pointer to what? No members available. Why? If you don't mind me asking, why the fuck not? Okay. Okay, bro, I got it. It's cool. It's cool, bro. I got it. can't live without me IntelliSense. That's just instance. Fuck you. You too. Oh, I hate you. Pointer to X, and I'm just gonna copy and paste this. Can't trust my keyboarding skills. And now we need to get the sprite that we're doing, which is instance pointer to template pointer to frames at instance pointer to current frame. And this one has to be an address, because you're giving it the address of the sprite to be drawn. Just put that like that. Fuck off with your fucking D. I did not want a D there. Alright. So now, all this nastiness, we just have to call it with a pointer to the instance, and all this is taken care of. Put that back there. Alright. So let's try a very simple thing here. We don't need frame number anymore. You can go to hell, bro. And we'll go game.h. Alright, so these three things here, together they represent the template for the dude. And then down here, animated sprite instance dude. So we go game.cpp, we load a sprite, and we create sprite instance with a pointer to our dude template, address of our dude template, same thing really, and the address of our dude. Alright. Now, let's get rid of this stuff. Get rid of that one. Update animation. Draw sprite instance. Go. Okay. So, dude, what's his speed gonna be? Dude dot x plus and equals 0. Say speed is 1.5. I don't know. Seems like a good speed to me. We'll see once we see him walking if it's too fast or too slow. So we change his position, and then we go update animation and dude, and then down here we go draw sprite instance and dude. So that should give us a dude that walks from the left of the screen to the right and then crashes the program. Okay, well the dude is sliding, but he's not walking. That's a mighty fine slide you got there, but I was expecting a little bit more from you, dude. Okay, what's the problem? Update animation. Right, because we're not actually... What we failed to do here is we failed to instance pointer to increment the exposure value. We just test it. We don't increment it. So yeah, of course he's going to be moonwalking or whatever he's doing there. Now we got the dude walking. This doesn't seem too bad a speed for... and crashed it. And he crashed. Way to go, dude. Abort. Okay. Now we're just going to do something a little bit different. Just to show how this can work. And then that'll be the end of this lesson. So we're gonna go game.cpp game.h. Yeah. Animated sprite instance dude. Let's make 60 dudes. Actually, fuck that. 1 second. I'm gonna be right back. All right, I tried to fix the animation, but best I can do here. Oh, I did one minor change here. I made another constant here. I defined constant for the speed of the dude. But I couldn't really fix the animation that well. There's a problem with the frames. You look at his arm, he kind of does a weird thing here. The legs work pretty good, but the arm is a little bit fucked up. So that's that. Now, as a final test here in our game extraordinaire. It's not a game really, it's just a test. We're gonna make... Wait. Let's make another define here. While we're at it. Define ndudes is equal to 60. Alright. Now we're going to make a whole shitload of dudes. So we'll load our animated sprite. But then instead of creating one sprite instance, let's do stdlib include time.h. Yeah, you know what's coming. Alright. Index equal to 0 as long as index is less than n dudes. Index plus plus. Alright, now I wish I didn't delete that. Create sprite instance. Dude template. What did I call it? Dudes. Address of dudes at index. So we'll load up our sprite. And then dudes dot x is equal to rand. What do we got here? Rand, I gotta seed rand first, don't I? Work. srand time null. There. Now, rand mod screen width minus minus dude template dot frame at 0 dot width. Yeah, there we go. That'll give me a number between something and something else. Please tell me this one has the screen width and screen height. D3D graphics.h. It doesn't, does it? Damn it, when did I write that? Whatever. Must have put that in the framework afterwards. Mumbly. Okay, let's keep going here. Oh man, we already got 2.5 hours. Sprites.y 600 height. Okay, now that will be all for our initialization. Wait. No, I want to start them on random frames. I don't want them all to be synchronized in the way they walk. So in that case, dudes index dot current frame is equal to rand ampersand dude template dot end frames. There we go. Now they'll all start on different frames. So this will initialize our dudes. Now we want to update our dudes. So index is less than in dudes index plus plus. So dudes at index dot x plus equal to dude speed. If plus whatever, fuck that, plus dude width is greater than 800 799. What do we think here? It's greater than or equal to 799. Play it safe. There. That will handle wait. And dudes at index. There we go. There we go. So that will handle the updating of the position and the animation of all of our dudes. And then here, you know what? Fuck that. Here we go. Dudes at idnex. Yeah. Alright. So, I think you can guess what this is going to do. It's time to create our army of stickmen. Or it's time to crash the program. Nope. Program not crashing. But here's our army of walking stickmen. That's kind of cool. You can see the outlines here, the white outlines. It's not the prettiest thing. And that's because of the anti-aliasing that was applied when I rendered these stickmen here. So they actually have an outline that's gray colors that aren't perfect black or white, but somewhere in between. So on a white background it looks fine, but as soon as you get some black there, you can see the outline of the anti-aliasing there. So that's a problem. There's a couple ways of solving that, but I guess the simplest is just don't use anti-aliasing when you're rendering your sprites. So yeah, that's sprites, and I just showed you guys a way to create structures and functions that will allow you to compartmentalize all your sprite data into discrete objects or object-like entities. I just want to look at this now. I've been working on this for a while, actually. Ooh. So next lesson we're going to be learning about dynamic memory allocation, and that will be very useful for when you're allocating large amounts of memory, or when you're allocating memory and you don't know ahead of time what the size of it is. I don't know what to say other than that. I mean, here's one thing. When we are creating our animated sprite template, we need a separate two separate arrays here in order to allocate this. But if we can use dynamic memory allocation, we can get rid of these two arrays and just have one dude template structure, and that would be enough to keep track of the whole template. And another thing is we don't have to use this thing where we put all of the surfaces into a single array. We won't have that once we can do dynamic memory allocation. We'll have an array of pointers, and each pointer will point to a separate surface. But in order to do that, we need, or in order to do it properly, we need dynamic memory allocation. So stay tuned for that in the next lesson. And now I am going to rest my throat because it feels like bloody hell. So until next time, keep your stick on the ice and all that good stuff.